Guyana's telecommunications market is expanding rapidly, creating a massive commercial opening for local internet service providers, especially in growing corridors like Plaisance. But operating here means confronting three specific obstacles that will quickly take down a standard network: an unstable electrical grid, severe signal dropouts from tropical rain, and strict national import regulations. To succeed, you need a highly specific roadmap. We are going to map out exactly how to register your business legally, architect a hybrid Starlink to fiber network, and build an off-grid power system to survive the environment. Standard North American WISP playbooks assume stable power and clear skies. Relying on those assumptions in Guyana will lead to immediate hardware failure and regulatory fines. You need a strategy engineered specifically for this terrain. Your first step is legal compliance. You must file for Small Internet Service Provider, or SISP, status with Guyana's Telecommunications Agency. This comes with a flat fee of 120,000 Guyanese dollars, plus an ongoing regulatory requirement to pay 3% of your annual gross revenue. Next, because you will be broadcasting internet wirelessly to your customers, you have to apply for a 5.8 GHz frequency authorization to legally operate your local distribution hubs without causing interference. The most critical error new operators make happens right here at the border. If you ship RF equipment or Starlink kits into the country before securing a dealer's permit or import license, customs will seize your hardware. Securing these licenses first ensures your business is protected. It upgrades you from an unauthorized reseller at risk of confiscation to a legitimate, recognized digital utility. With a legal framework in place, you can build your data backbone. We start by deploying 2 to 3 Starlink High Performance kits on business priority plans to secure high-speed, low-latency bandwidth while staying strictly within Starlink's terms of service. However, the Starlink system relies on K-band frequencies, which degrade heavily when tropical rain hits 25 millimeters per hour. To solve this, you pair the satellite array with a local terrestrial fiber line from a provider like GTT or eNetworks. The brain managing these inputs is an enterprise router, the MikroTik CCCR 2004. Inside, we configure a per-connection classifier to bond the Starlink connections into a single massive data pool. The fiber link acts as an SD-WAN failover, constantly monitoring the satellite connection. If a massive tropical downpour blocks the satellite signal, the router instantly reroutes critical traffic to the fiber line. Your customers keep their internet access without noticing the disruption. Even with bonded Starlink dishes, priority data is expensive. When your customers start downloading massive 100 gigabyte gain patches or operating system updates, that priority allowance will drain rapidly. To solve this, you deploy edge computing, a local AMD Epyc-based server running software called LAN cache, alongside a local DNS resolver. When the first user on your network downloads a large update, LAN cache intercepts it. The server stores the file locally, and any other customer who requests that update gets it directly from your tower at a full 10 gigabits per second. This local memory node drastically reduces the amount of data pulled from space. It acts as a bandwidth multiplier, making a satellite backhaul feel as snappy and responsive to the end user as a direct urban fiber connection. Now we have to protect this equipment from Guyana's famously unstable electrical grid, where power surges and blackouts are routine. A central hybrid inverter isolates hardware, managing energy between a 4.8 kilowatt solar array, battery bank, and the grid. Programmed with utility-first logic, it uses the grid to keep batteries charged. If the grid drops, the inverter executes a sub-10 millisecond failover. Your network stays alive. For prolonged outages during the rainy season, your ultimate failsafe is an 8,500-watt dual-fuel inverter generator. By running it on propane, you completely bypass the region's frequent gasoline shortages. This multi-layered power immunity effectively builds a wall between your delicate routing hardware and the local infrastructure, ensuring your WISP stays online even when the entire neighborhood goes dark. Enterprise-grade routing, caching, and power hardware requires significant capital. To make the business model work, you have to actively lower your initial costs. The Guyana Revenue Authority offers specific tax exemptions to leverage. By correctly classifying your solar panels and deep-cycle batteries as renewable energy equipment, you qualify for 0% VAT and 0% import duties. You can also use your active SIS status to petition the Ministry of Finance for duty-free concessions on your heavily taxed RF networking gear. Aggressively navigating the tax code cuts thousands of dollars off your upfront expenses. Managing your import duties is as critical to the long-term survival of the business as managing your network traffic. You now have a legally compliant bonded multi-gigabit network. It caches its own heavy data and generates its own power. The final operational step is connecting it all to remote management software. This gives you a single global dashboard to monitor battery levels, grid status, and signal strength from anywhere. This blueprint builds a resilient, profitable digital utility capable of delivering consistent connectivity to underserved corridors like Plaisance. By combining global satellite reach with local infrastructure, you create a network that stays online when the traditional grid fails.